In this video, I'm going to talk about functions. I'm going to explain what a function is in nice and simple terms and then go through a few examples. In the next videos, I'm going to talk about plotting functions, finding roots, and also give examples of functions in some real-world cases. Okay, so first of all, what is a function? When I think about a function, I think about a conveyor belt. Okay, so imagine this is a conveyor belt like in a factory. You put something on here and it moves down the conveyor belt and comes out over here. And in the middle here, I'm going to put this machine. Okay, and we're going to give this machine a name. We're going to call it F. Okay, so this machine has input coming from the left and then output going out the right like this. Okay, now what goes into the machine? Well, we're going to put numbers into the machine, and numbers are going to come out of the machine. For every one number that comes in, one number is going to come out. So a number comes down the conveyor belt into the machine. What does this number machine do? Well, it can add something to the number, it can subtract something from the number, it can multiply, it can divide, it can square the number, it can do anything like that to the number, as long as you just get one output. Okay? So in the simplest terms, that's what a function is. Okay, that's all it is, and we'll see this working with these examples in a second. Okay, now when we have an input and output pair, we often just put them in brackets like this with the input number first and then the output number second. Okay, so that's the first thing I'd like to say. Okay, another thing is that in mathematics, we don't want to say like that the number that goes in is like a symbol, like a box or something like that, like a placeholder, like a box, or like a word like input. We have a convention. We usually use this X. We use this a lot of the time. And this X, we understand that this just means a number. We don't know what number this is. It can be any number off the number line, but we just have X represents, could be, it's a placeholder, could be any number. And then X goes into the machine. The machine jumbles it up and then spits out the output, and we call the output f of x. Now, typically you can often see f of x, it could be written as y, so you could have your x value in and your y value out. But here in this example, I want to use this f of x notation because we're talking about functions. Okay, so that would mean that our input-output pair can be written like this. So our input is then x, and then our output is then f of x. Okay. Now, the last thing I'll say is that when this whole sort of conveyor belt thing being used in practice, we have this f of x notation. And what we mean by this f of x notation is that this x here inside the brackets, this will be the number that goes into the function f. So that's this part of it here. This is the number that goes into the function here. And then when we put that in, then we get out an answer. That's going to be our output. Our answer on the right-hand side here will be our output. Okay, so let's see this working with a specific example. And what I want to do here is talk about a linear function. Okay, now if we were to make a graph of a linear function, a little bit of a clue what's coming up in the next video, the word line is there. Okay, so an example of a linear function. So what is a linear function? So a linear function will be something like this. F of x is equal to something, added or multiplied. There'll be one x there. So let's say, for example, 2x plus 3. There's an example of a linear function. So one x appears on this side here, and there's no squares or anything like that. And this is an example of a linear function. Okay. So what does it mean? It means you take the number that you take in, first of all, multiply it by 2, and then add 3. So that's like what's going on inside of this black box, inside of this machine here. The number comes in, first of all, it gets multiplied by 2, and then you add 3 to it. That's what's being said, what's happening with this function here. Okay, so let's try it for a given example. So let's take f of 0. Okay, f of 0 means that the number coming into the machine here is a 0. Okay, so if we put a 0 into the machine, it's 2 times the 0 plus a 3. Okay, what's 2 times a 0 plus a 3? Now, incidentally here, I just usually put this number, whatever number has gone in place of x, I usually you're just replacing x wherever you see it with that number, but I often put it in brackets like this just to make it clear that we're putting this number in place of x. You don't need to use that brackets at all. You could do like 2 with this little dot. That's not a decimal, that's a multiplication dot, right, because it's down low. 2 times 0 plus 3, or you could write it as 2 multiplied by 0 plus a 3, okay? But as I said, I just use this brackets notation just to make it clear that that's going in place of x there. Okay, 2 times 0, that's a 0, and then a 0 plus a 3 is just a 3. And if we were to go and write our input-output pair, so our input-output pair, remember, was x and then f of x, right, as our input-output pair. Okay, here we're going to write down our input-output pair. 0 was the number that went into the function, and then 3 was the number that came out of the function. Okay, so let's try it again. So f of 1 this time, okay, this is 2 times a 1 plus a 3. Okay, so that's 2 by 1, that's a 2, and then plus a 3, that's a 5. So our output here, our input was a 1, and our output is a 5. Okay, so you can see that we're writing down this pair of input in brackets like I said before. Okay, so f of 2, this is 2 times 2 plus a 3. Okay, 2 times 2 is a 4, and then 4 plus a 3 is a 7, so then we end up getting 2 and 7. Okay. Now, before we move on to the next example, we can see a pattern coming about here. We can see in our input numbers, each time it's going up by 1, and our output numbers, each time it's going out by 2. Now, if we really want to see the pattern of what's happening with this function, then we can draw a graph, and I'll do that in the next video. That's the best way to see like what this function does. What does it look like? Okay, so the next example I'm going to give is a quadratic function, and then a quadratic function. A quadratic function is the same as a linear function, except it's going to have a quadratic term in it. So let's take this example. Okay, so if this minus 5x plus 3, this is like the linear case from before. We had one x in it and the x wasn't squared or anything like that. Okay, the difference with the quadratic function is that we'll have this x squared term as well. So it could be 2x squared or minus x squared or anything, but there will be an x squared term as well as it. Well, not always with the x term, but there'll be an x squared term there as well. Okay, so let's try put in a few numbers. So we put in a 0, 0 squared minus 5 times 0 plus a 6. That ends up giving us 6. Okay, now we're going to do our input-output pair. So there's our x, here's our f of x. Okay, so we put them together in brackets for our input-output pair. And here you can see we put a 0 in and then we got a 6 out. Okay, so let's do it again. F of 1, this is 1 squared minus 5 times 1 plus a 6, which ends up being a 1 and a minus 5 and a plus 6. So the 1 and the 6 give me a plus 7, and then I end up with a plus 2. And my input-output pair is 1 and 2. And let's try now put in, finally we put in 2 into this function, and we see, we'll put a 2 into this function, and then we see, okay, this is 2 squared minus 5 times 2 plus a 6, okay, which gives us 4 minus 10 plus a 6, and then the 4 plus the 6, well, that's a 10, and then a 10 minus a 10 will be 0. So then we know that if we put in a 2 as our input, our 0 then is our output. Okay, so now if we look at these outputs, these pairs of input and output, okay, we can see as we increase each time by 1 for the input, the output does something kind of funny, like starts at 6, then it goes to 2, and there isn't necessarily a discernible pattern. in the last case, we could say that the output increased by 2 each time, but this time here we can't really see exactly what's going on, and that's why it will be important to make plots so that we can see, make plots and find roots so we can really see what's going on. Okay, just before we finish, I'll just give I'll give another few quick examples of function. Let's say, for example, we could have a function that was equal to x cubed. Okay, well then f of 1 would just be 1 cubed will be equal to 1. Or f of 2 would be equal to 2 cubed, which is 2 by 2 by 2, which is 2 by 2 is 4, so 2 by 4 then which is 8. So you can dream up any function that you like. Let's say x squared minus x divided by 2x plus a 3. Okay, well, what's f of 5 then? Well, f of 5 is just 5 squared minus 5 over 2 times 5 minus 3. You see, you just put them in, so that's 25 minus 5 over 10 minus 3, which ends up being 20 over 7. So you can see that for all of these different functions that we have, you put in a number, you have your input number, you have your input numbers, and then you get your output numbers. Okay, so that's all that's going on with functions. So the function is a number machine. This tells you what's going on inside the machine, and then you put a number in, and then when you put it in, then this side here will tell you what to do with the number. Here you square it, then you subtract the number again, then you divide by, multiply by 2, and so on. Okay, so that's the first part where I talk about functions, and in the next part I'll talk about plotting functions.